This device can read your mind. And it might also be the world's most advanced tool for diagnosing Alzheimer's. It combines brain scanning EEG technology with machine learning algorithms to dramatically increase the effectiveness and reduce the cost of early detection.
All right, demo, take one, Mark.
And these are the guys who invented it.
So look into the camera, right?
Yeah, looking right into the camera.
Should I start talking or? Hey, I'm Drew.
I'm Chris.
They're sophomores at the University of Maryland, and they're DIY scientists.
My name is Dhruv Patel.
My name is Christopher Look. Dhruv and I met in high school. We didn't really know each other too well back then.
But we connected in college our freshman year when we went to the same bioengineering society.
We said, why don't we try to form a team and come up with an idea?
Let's do something that's personally affected us before.
Happy birthday to you. Happy birthday to you.
So Alzheimer's is a neurodegenerative disease, and it's one of the most common causes of dementia. It's truly a horrible disease.
Your brain just starts to fail. You start to lose parts that make you who you are, all the memories of your past. It's not just the patient that's affected.
My grandfather was actually diagnosed with Alzheimer's at a pretty early stage.
My grandmother was taken from me by Alzheimer's, and so I wanted to tackle this problem head on.
You know, seeing that firsthand really empowers me to do more research in the field and reminds me of why I got in it in the first place.
One of the biggest problems is diagnosis. So right now, the current Alzheimer's diagnosis, it takes about 1 to 2 years, maybe some $45,000, and it always happens too late.
So we're developing a novel way to detect the disease early on.
The way we're doing this is using electroencephalogram technology. It's essentially like a brainwave scanner. What we're trying to do is combine that with machine learning to diagnose Alzheimer's.
Hi, I'm Dhruv.
I'm Chris.
And this is our open source portable EEG headset from OpenBCI that we use to measure brainwave activity. Here you'll see the electrodes that are placed on the scalp of the brain, which are then used to record the electrical firings of neurons within the brain. That data is then sent to a microprocessor right here, which is then transmitted to a computer via Bluetooth for further data analytics.
And so the computer will take that EEG data, it'll do some data processing, and then we'll put it into a machine learning algorithm. That machine learning algorithm has already learned the differences in EEG readings from those who have Alzheimer's and those who don't. And then we'll output a diagnosis for the patient that is currently using this device.
So once we had developed the machine learning algorithms and really inputted all of the data that we could possibly find, Chris came out with a message saying, hey, we just got 83% diagnostic accuracy. And we said, you know, heck yeah. That had been higher than what current researchers are doing with lots of resources.
And so we said, okay, so this is definitely possible, and we can definitely improve on this in the future.
This technology is a game changer. Earlier detection of Alzheimer's will lead to better clinical trials, which means better treatments, and eventually a cure. So Chris and Dhruv have turned their DIY project into a startup called Synapto, and it might not be long before this device makes its way to your local doctor's office.
EEGs have existed since like the 1970s. Usually they're like big machines that take up half the size of the room that they're in. But recently, companies have been coming out with like portable and affordable EEG technologies. We built it and everything. We 3D printed all the parts, we assembled it. We compare our algorithm with this device to make Alzheimer's diagnosis more accessible, because devices like this do exist now.
Access to 3D printers, access to a lot of new software and a lot of new technology is really integral, as it allows people from around the world to hack into what's going on in the brain. We hope to be able to put this device in every doctor's office, and maybe even collaborate with big pharma companies who are already conducting drug research and help them assess the severity of Alzheimer's disease using our technology.
So I think the freedom that DIY gives you is fantastic. It inspires innovation. You can have more people trying out different and diverse ideas. I can do this on my own now, and I don't need to rely on the approval of all the adults that are around me.
I think DIY science is really what's changing America's industries, and it's what's really propelling the entire tech sector. People starting from their garages, people starting from their dorms, people starting from the ground up is what's really going to propel the next breakthroughs in science, technology, and medicine. The best time to do DIY is now. Anyone with a laptop or a computer and the intellect and motivation to do so can build extremely great things.